Okay, so now we're going to practice finding the derivative using our power rule. So just some simple examples to start. One thing that you would want to do is make sure that you're moving your coefficient down first and labeling that this is now f prime of x, right? So f prime because we're taking the derivative. Now, leave this coefficient there. The 6 still comes down. The 3 stays. X stays. And now that 6 becomes a 5 because remember that once we move that down, we also subtract 1 from it. Now, anything remaining now gets multiplied together as coefficients. So 18x to the 5th, done. Okay, number 2, next to it. This one is the same concept. Notice how it's just separated by plus and minus signs. There's no product rule, there's no quotient rule. I just have to find the derivative of each one of these 3 things separately. So we're still going to label our derivative f prime of x. And then from here, we're just using our power rule. So I move the 3 down, that becomes a negative 3. I subtract 1 from that exponent, that becomes a 2. Now, remember that this one here has an exponent of 1. So if I move that down, I'm really doing 1 times 2, which is going to stay 2. Notice how I'm bringing this positive sign down. The x is going to stay, and our exponent, if we subtract 1 from that, is going to become 0. We'll talk about what to do with that in a second. Also remember that we cannot use a power rule for constants. The derivative of any constant is going to be 0. So now I'm just going to clean this up. We can leave this negative 3x squared on there. Okay, but 2x to the 0, x to the 0 really just becomes 1, and 2 times 1 is just 2. So essentially, anything that started with an exponent of 1 is going to turn into a constant here. Here's our derivative. Okay. Now for these next 4 problems, this is where the heart of this is going to be, and this is where a lot of people have been getting confused. Okay, so what happens if I have this on the bottom? A lot of people think that, oh, I'll just move the 3 down and take my power rule at the bottom and I'll just leave everything the same. Not exactly true. Okay, the very first thing you need to do is you need to rewrite this. And we practiced this yesterday, rewriting things that have a number in the denominator. So we're just going to leave the 5 as the coefficient. We're going to leave that out front. And this x to the 3rd is going to become x to the negative 3. Okay, remembering that there's a relationship between negative exponents and it being on the denominator. Now, this is not my derivative. These 2 things are just the same. So when I find the derivative, now what I'm going to do is I'm going to write this as f prime, is I'm going to take that negative 3, bring it down, leave the 5, and with that x, we're going to subtract 1 from it. So that's going to become a negative 4. So our derivative is going to be negative 15 x to the negative 4. And one thing that we should constantly be thinking about is, should we have a negative exponent as our answer? And generally, the answer to that is no. So all we have to do is change this back. Well, negative 15 was the coefficient, so we're going to put that just back on top. And we're going to put this x to the 4th back on the bottom. Why? Because negative exponents and denominators pretty much go hand in hand here. All right, so this is our final answer. Here's our derivative that I want to see. The 4th one, just doing these piece by piece. Okay, take the derivative of each one. So before I even take that derivative, what I should do is I should rewrite this. And the only thing I need to really rewrite is this 4x to the negative 2nd power. And what you need to constantly be thinking about is, okay, why did that become a negative? It was in the denominator. Where did the 4 go? That was the coefficient. It stays the coefficient. Now I can finally take my power rule and take the derivative. So now I can actually go down and write this as f prime and take the derivative of each one of these things. So the 3x, if I take that derivative, remember the 1 comes down, that stays a 3. The x becomes x to the 0, so that's gone. If I bring this negative 2 down, I'm going to have a negative 4 times a negative 2, x. And if I subtract there, I'm going to get a negative 3. Remember that the derivative of any constant is still going to be 0. So now I'm just going to clean this up. I can leave the 3 as just a 3, but all of this is going to turn into a positive 8, x to the negative 3. And you should remember from that last problem what we do when we have a negative exponent. We're going to put it in the bottom. So we're going to make this 3 plus, leave the 8 on top as the coefficient, x to the over x to the 3rd power. There's your derivative formula. So understanding the relationship between negative exponents and where to put them in a fraction. The next 2 problems. We have radicals. This is another point of concern for us. Once again, all we're going to do is we're just going to rewrite this. So we're going to leave the coefficient the same, leave that as like 3 times. But over here, what we have to consider is, okay, I still have an x, but I now know that radicals are going to turn into fractions. Well, what fraction will this turn into? Okay, inside number goes on top, so that's going to be 2/3. This is not done. This is not my derivative. This is simply rewriting it so I can use a power rule. So now when I come down to f prime, I need to move some things around. First thing I need to do is I need to move this 2/3 out front, and then I need to subtract 1 from it. So I'm going to have a 3 times a 2/3 out front. I'm going to make that a 3/1, just so that I can multiply these fractions later. X, and then if I subtract 1, that's really subtracting 3/3. That's going to be a -1/3. Okay, we have a lot of cleaning up to do in this problem. This turns into 6/3. 6/3 is divided to get 2. And that's 2x to the -1/3 power. Now, there's still some cleaning up to do. Again, there's 2 things that I have to do. One thing is I have to rewrite this in a couple of different ways. I want to rewrite this so that it goes on the bottom. Now, already you should be thinking, why does that go on the bottom? Well, because it's a negative. And the next thing I should be thinking about is, how do I rewrite 1/3? Well, how did I change from a radical to a fraction here? Okay, well, now I'm going from a fraction to a radical. So the 1 is going to go on the inside as the exponent, just like the 2 was up here. And the 3 is going to stay on the outside. So our final answer to this problem, let's put this x inside a radical, and then let's figure out what happens here. Sorry, that 2 is going to stand out. Put the x inside a radical, and then the 1 is going to become the power, and the 3 is become the root. And that would be my final answer. Okay, I'm going to skip past this one so that I can get some examples down here. So once again, with radicals, radicals are related to fractions and fractions back into radicals. So if we look at, let's go down to the following 2 problems. We have to find the slope of the tangent line. Now remember from the earlier video, the slope of the line tangent to is going to have the same slope as this at that point, if I find the derivative. So the very first thing that I'm going to do is I'm going to rewrite this. I can see that it's in the bottom. We're going to rewrite this as 3 times x to the -2nd power. I kept the coefficient. I just changed this to a negative because that's what happens with exponents on the bottom of a fraction. Now, if I find y prime, it's just a power rule. Bring the -2 down, that becomes a -6. If I subtract 1 from that -2, I get a -3. Now, we cannot just plug in this 2 yet. We have to continue solving and simplifying this. So let's just clean this up. The -6, which is a coefficient, can stay on top, and then x to the 3rd is going to go on the bottom. Now I can actually plug in y prime of 2 for my x, and I get -6 over 2 to the 3rd power. And no, that's not going to be 6 over 6. 2 to the 3rd is 8. So that's going to be -6 over 8, which is -3/4. That is my slope. That is my rise over run of this line at this point. The very last problem, very similar. I am given this problem in a radical. So you should immediately be thinking, what do I do with a radical? I should be writing a radical as a fraction. Okay, so 9 stays out front. Well, on the inside, that's what I'm putting in my numerator, and on the outside, that's what I'm putting as my denominator. Notice how I haven't taken the derivative yet. I'm still still rewriting this. Now I can actually do my power rule. So now the 3/2 can come down out front. The 9 is going to stay. I'm going to write that as 9/1 so I can once again simplify that. And then I have to subtract 2/2 over here, which is 1/2 to give me 1/2. Now for this one, we're going to get 27/2 x to the 1/2. Now remember, a 1/2 just turns that back into a square root. Imagine there being an invisible 1 here and an invisible 2. So now we're ready to plug in. So when we can now plug in x equals 4 to find that slope at that point. Remember, slope is just the same thing as instantaneous rate of change. So I'm going to keep that 27 over 2, and we're going to multiply that by the square root of 4. And that's going to turn into 27 over 2 times 2. Now, a quick shortcut is we can actually cross cancel with those fractions, and that's going to give me a final answer of 27. All right, your turn.